All right, welcome back. In this section, we're going to be going through Module 3, Topic 3, Lessons 1 through 4, and this video is designed to be an introduction to lead into those sections. This section, or these sections, we're really putting it all together. There's not a lot of new information being introduced. It is putting together a lot of the pieces we've done before individually, and trying to be able to move from one of those pieces to the next, to the next, to the next, without difficulty. We're going to be focusing on linear equations. So a linear equation is the equation of a line. It is in two dimensions. It has an x-axis and a y-axis. We're going to be focusing on sentences. Sentences are just problems, word problems or sentences. Equations. Those are going to be in the form y equals mx plus b. Again, don't panic. We're going to be focused on tables and charts and the data they display. And we're going to be focused on graphs as well. And again, working between any of these four, if you're given one, can you produce the other three? Don't panic is first on my list. Second on my list is really don't panic. You've all done quite a bit of work with all of these topics individually. Again, now we're just going to learn how to move from one model of showing a linear equation or inequality to the other three. So let's talk about some advantages and disadvantages of each. And this is actually the Talk the Talk page on page 136. So this information will come back into play. The advantage of a sentence. And again, a sentence, it's just a word problem. An advantage is they show a real-world application, and they help show the information you need to understand the problem in context. A disadvantage, they might make it difficult to apply this to other types of problems or to see where it's going. It takes effort to see what is happening when things change. Tables. Table is a display of data, usually 5 or more coordinate pairs. You give me an x, and the equation spits out a y. An advantage is it gives me specific values to work with. And another advantage is tables or charts help you see patterns. A disadvantage, they're not as helpful in finding other values. It's hard to get the values between the values at times, or to get a distant value that's not really on your chart. Graphs. Graphs, advantage, they are great for displaying the big picture of data, patterns, and trends. Graphs are probably the best at showing that information. The disadvantage of a graph is the points on a graph tend to be hard to use to determine the exact value. Unless one of those points hits perfectly right where an x-coordinate and a y-coordinate meet, then all you're doing is estimating or guessing their values, trying to get really close. So they're imprecise. And then equations, they tend to be my favorite. I tend to like to put everything into equations and then use those equations to generate the other components, like to generate a table, to generate a graph, or to generate a sentence. Equations allow me to generalize the problem. They don't give a lot of specificity with what that problem is applying to, but they're great when you're ready to turn it into these other areas. Equations also allow me to calculate exact values. The disadvantage of equations, they don't provide a visual representation to see patterns, and they don't provide context that allows you to see the applications in real life. One of the hardest things for me is to take an equation and turn it into a sentence. And you will have different strengths and weaknesses. You might like graphs better, tables better, sentence. I tend to prefer being given an equation and then turning that into everything else. So let's take a look at what I mean by taking one and turning it into the other three. I'm going to just do a few examples before we go into the section, before we even go into this whole topic. I'm going to set some examples up that you can then use if you want to go back and review a video. to see how to do it when we're working through these other problems. Let's say they gave us a number sentence, a real world word problem. And again, I'm just keeping it simple because I want to show the mathematical concepts, and I'm not ready to overwhelm with fractions, decimals, percents, and things that don't fit. So I just chose Mary had 2 little lambs whose fleece were white as snow. She increased the size of her flock by 1 lamb per day. So again, she starts with 2. Every day after that, she's adding another sheep to her flock. So the things that are changing in this problem, I'm going to take this and turn it into a table first. And there's the number of days. That changes. And then the amount of lambs, the total amount of lambs. That changes. The total number of lambs is dependent on the number of days. The more days implies more lambs. Less days, less lambs. So this is the dependent. That's going to be the y-axis. It's also going to be called the output. Lots of different names. And you're going to hear Mr. Durfee and your 9th grade teacher use some different terms for this very same thing, the dependent quantity. The independent quantity in this case is the number of days. And I'm just going to say that that's your x value in a coordinate pair. So let's put in some of the given values. Again, if at 0 days, how many lambs did Mary start with? We said she started with 2. On a coordinate plane, this would be coordinate 0, 2. After 1 day, she adds a lamb, so now she has 3. After 2 days, 4. 3 days, 5. 4 days, 6. 5 days, 7. 6, 8, 7, 9. As number of days goes up by 1, number of lambs goes up by 1. If remember the constant of proportionality, k, was the y value over x, you're going to, in simplest form, y over x, we're going to be going into slope, and you're going to spend a great deal of your 8th grade year talking about slope. This change in y over change in x, when x changed, I'm going to put x and y, when 2 coordinate pairs, the y value in this one is 4, the y value in this one is 3. 4 minus 3 is 1. The x value in this one is 2. The x value in this one is 1. 2 minus 1 is 1. The rate of change is 1 over 1. So when x grows by 1, y grows by 1. Let's put this into a graph. I'm going to label my graph. Again, I've got my x-coordinate, I've got my y-coordinate, and I'm just going to use intervals of 1. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We're really not talking about having negative lambs, that Mary's not owing anybody lambs. So we're going to focus just on this first quadrant. Quadrant 1 just deals with positives. And on the very first day, so when x is 0, that's this y-axis, when x is 0, we said Mary started with 2 lambs. If we're up here, when x is 0, that's x, that's y. When x is 0, y is 2. That's the coordinate. x0, y2. When x is 1, y is 3. When x is 2, y is 4, 5, and it's going to, the number of lambs is going to grow by 1 as the number of days. So what we're dealing with is number of days is the x-coordinate, the independent, and the total number of lambs is the y-coordinate. And this graph, now Mary never has 1/100th of a lamb, 1/8 of a lamb, 1/16th of a lamb. She's getting that whole numbers. So it makes sense here just to put dots as she's adding them. It's not a continuous line. It is discrete. Dots or dashes represent a discrete line. It means not every value is included in here. We're not talking about Mary picking up half a lamb in half a day, or 1/100th of a lamb in 1/100th of a day. She's picking up whole numbers. At one day she picks up whole lamb, another lamb, another lamb. So this line is discrete, not continuous. Now, my favorite, the one I prefer to start with, is the equation. And the equations are going to be of the form y equals mx plus b. We only need two pieces of information here. We need to know the slope, and we need to know the value for y when x is 0. So when x is 0, where does this cross? At 2. When x was 0, y was 2. So this b value is a 2. So we have y equals some value times x plus 2. Now, to get the slope, we have to figure out how far up it goes, how far over it goes to get to the next point. If we're here at 2, we go up 1 to 3 and forward 1. Slope, or if we have two coordinates, y2 minus y1 over x2 minus x1. So my slope is how steep the line is. It's like a ski slope or a snowboard slope. The bigger the number, the steeper the slope. 0 is 0 fun because it's perfectly flat. If it's a cliff, if it's vertical, you can't snowboard or ski down that. You're falling down. So that's not a slope. Slope doesn't apply to a vertical cliff. So in this case, I'm going to take two coordinates. It doesn't matter any two out of my table. I'll take when x is 3, y is 5. When x is 4, y is 6. So one of those coordinates, x is 3, y is 5, and the other coordinate, x is 4, y is 6. And I'm going to rewrite those. And again, the first coordinate is x, the second coordinate is y. I'm throwing a lot of information at you, so please don't panic yet. Just try to follow along to the best of your ability. We'll be doing some more of these. So one y value over the other, subtract the other y value. 6 minus 5 on top. 6 minus 5. Then the x that goes with the first y is 4 minus 3. 6 minus 5 is 1. 4 minus 3 is 1. 1 divided by 1 is 1. So the slope is 1x. And we would just literally write this as y equals x plus 2. That would be the equation. And again, please don't panic. We went through a little bit of this. You're going to be going through a great deal of it, 8th grade year and 9th grade year. The more it makes sense now, the easier those 2 years will be. But again, don't panic if it doesn't make sense at the end of your 7th grade year. People learn math at different rates, different times. Some of the best math teachers and mathematicians I've come across found it very difficult when they were younger. They actually thought they were horrible at math. And it just, when it clicked with them though, it clicked. It makes sense. And Kathy Anderson is a professor at Shasta College. She is amazing mathematician and at Language Arts. Marlene teaches at Tehama District Office, just an amazing mathematician and teacher. So please, again, don't panic if it doesn't make sense right away. There's plenty of time to learn it. If you're trying and the sooner it makes sense, then the easier 8th and 9th grade will go. But again, math is a marathon, it's not a sprint. All right, I'm going to start with a different. This one I started with a sentence and I did the other three. This time I'm going to start with a table. And I have these values. I'm just going to graph them right away. When x is 0, so I'm going to work on a diagonal here. I'm going to graph this pair first. X0, y negative 5. Negative 1, negative 2, negative 3, negative 4, negative 5. And then when x is 1, y is negative 3. So it would be right there. When x is 2, y is negative 1. So when x is 2, y is negative 1. When x is 3, 1, 2, 3. Y is positive 1. And again, this is forming a line. I'm going to make this a continuous line, not a discrete. So whatever information is here, it's going to fill. And it's going to be going through, since it has negative values, this graph is going through the first quadrant, which only deals in positives, quadrant 2, quadrant 3, and quadrant 4. On my 4 quadrants on my number line. That's what my graph is going to look like. My equation, again, is y equals mx plus b. I don't need to find x and y values. Those ones I'm just going to put in. I'll put it in an x. My equation will give me a y. The only two I need to find are my slope and my y-intercept. Why they use the letter M for slope and B for y-intercept, I really couldn't tell you. But most likely it was done in another language where that makes perfect sense. All right, let's see if we can figure out the y-intercept first. This is the value of y when x is 0. And if we look up here, when x is 0, y is negative 5. So in this case, b is negative 5. Y equals some value times x plus a minus 5, which is the same as minus 5. Now I need to figure out how my line is changing, the slope. When x goes up by 1, y goes up by 2. So slope is the change. It is the change in y over the change in x. Slope is change in y over change in x, 2 over 1. 2 divided by 1 is 2. So in this problem, we start off at negative 5, and then we are increasing. The slope is going up by 2 every time. So let's think about something that might start at negative 5. Maybe you're going to sell something at a school fair. Mike and Mary are selling stick-on tattoos at the school fair. They bought $5 in supplies. And they sell the tattoos for $2 each. So this is tattoo sold. And this is money made. So we're not buying lower than that. So we're starting at negative 5, and we're really going up 2 at a time. So the situation that I described would actually describe a discrete graph, not a continuous. So this should be a dotted line, not a solid line. We started off $5, owing $5 because we spent $5 of our own dollars to buy the supplies. And then every tattoo we sell, we make money. So we have to sell 3 tattoos before we have a profit. If we don't sell any, we're just out $5 and we have a lot of stick-on tattoos. Hopefully, again, it's a little clearer, but I'm not expecting it to be much clearer at this point in time. I'm going to do a couple more of these, though, examples before I even start the math pages. In this one, I'm starting with a graph. And so when this graph is just growing by 1 each time. When x is 0, y is 0. When x is 1, when x is 1, y is a half. When x is 2, y is 1 on this graph. And again, sometimes it's harder on graphs to see the pattern. So I'm going to do the equation for this. Again, y equals mx plus b. The only 2 things I need to find are my b. That's this value. When we're on the y-axis, when x is 0, what is y there? Hey, that's a 0. And what is this value, the slope? When x is 1, y is a half. When x is 2, y is 1. So this thing is changing. When x goes up 2, y goes up 1. So this has a slope of a half. Y equals 1/2 x plus 0. Well, we don't even write that plus 0. This would just be y equals 1/2 x. Let's check to see if that really works. When x is 0, half times 0, y is 0. So when x is 0, y is 0. That would be a point. That would be a coordinate on our table or on our chart. When x is 1, a half times 1, y is a half. When x is 2, 2 times a half is 1. And we're seeing a pattern form. When x is 3, y is 1.5. When x is 4, what's half of 4? Half of 4 is 2. 3 times a half is 1.5. 2 times a half is 1. These coordinates I can put into a table just to show them. So this is when x is 0, y is 0. When x is 1, y is a half. When x is 2, y is 1. When x is 3, y is 1.5. When x is 4, y is 2. When x is 5, y is 2.5. Well, now probably the trickiest part of this is, well, trickiest for me, is taking an equation and turning it into a sentence. So I need something that starts off at 0 and goes up by a half of something per interval. I'm going to think of a plant. A bamboo plant. Grows from a seed at a rate of a ½ inch per day. And actually they grow faster than that. But in this case, my x is time. That's time in days. And my y is height in inches. The height of the bamboo in inches. So this is number of days. This is my x, my input. And height in inches is my y. The height depends on the number of days. So the more days, the taller this plant. And that's, again, how we can go from one to the others. Finally, starting with the one I prefer to start with is an equation, y equals negative 2x plus 6. Well, this value, this 6, is where my line crosses the y-axis. So, it crosses at 6, 1, 2, 3, 4, 5, 6. And that means on my chart, when x is 0, y is 6. And in this case, so that is my y-intercept. And in this case, it has a slope of negative 2. So whatever value I put in for x, when I put in, let's say, a 1 for x, y equals negative 2 times 1 plus 6. Y equals negative 2 times positive 1, negative 2, plus a 6. Y equals 2 bad guys, 6 good guys have a shootout. Good guys win. There's 4 of them left. So y equals 4. So when x equals 1, y is 4. When x equals 2, negative 2, y equals negative 2 times 2 plus 6, negative 4 plus 6, positive 2. When x is 2, y is 2. So this is growing by plus 1, and this is going down minus 2. So if the pattern continues, that went up by 1 to 3, that goes down 2 to 0. This goes to 4, this goes to negative 2. This goes to 5, that goes to negative 4. And then I can graph that as well. When x is 1, y was 4. When x was 2, y was 2. When x was 3, y was 0. When x was 4, y was negative 2. And if it's linear, it's going to be a straight line. If it's a straight line and it passed through the origin, that means it was proportional. This is not proportional because it's not passing through the origin, it's passing through positive 6. Well, now probably the trickiest part, at least for me, is creating a word problem that goes with this. So something is starting with 6 and it's losing 2 per some unit. I'm going to think of a bucket with water in it. A bucket has 6 gallons of water. And it's losing 2 gallons per some unit of time, per hour, per week, per day. I'm going to go per day. It's only 3 letters. It's faster to write. Per day. So a bucket has 6 gallons of water, and it's losing 2 gallons per day. Well, it really doesn't make sense to say that my bucket has negative gallons, so these ones really don't apply to the situation I just described, nor does my number line below 0. That doesn't apply either, because, again, my bucket's not going to have negative gallons in it. But that's just the one I chose, and it doesn't apply that direction either. And so I could have put in, though, like 1.5 or 2.5, 3.5, and so forth, and that would have been fine to show time. I can put any value for x in, and it's going to give me a exact value. So in here, we did examples where we turned one model, an equation, a graph, a table, or a sentence, into the other 3. By the time we get through lesson 4, through lesson 4, I'm hoping you'll be able to do the same. That given one, you can convert it to the other 3. Next, I'm going to be going into the math pages in the next video.